Another important application of percents is dealing with what's called the percent change. Now, here's a situation where we may talk about percent change. The enrollment at a local community college increased from 5,200 students to 5,400 students over the last year. By what percent did the enrollment increase? Typically, we are talking about percent changes and not the actual number changes, because if you think about 5,200 to 5,400, it's a change of 200 students. But if the college was going from 5,200 to 5,400 versus 50,200 to 50,400, we have the same absolute change, but we'll have a different percentage change, and it's better for us to compare those percent changes. Remember, when we're doing comparisons, percents are better. So how would we calculate a question like this? Well, we are going to figure out the total difference, and we'll do an absolute value here, 5,400 minus 5,200, and we will divide by where we started, 5,200. 5,400 minus 5,200 is 200, and since that is positive, our absolute value will be 200. Divide that. And we get 0.038. And as a percent, move that over 2 decimal places, and we get 3.8%. So I threw a few words out there, absolute change and this percent change. Sometimes we call percent change relative change because it is related, it's relative to where we started. So our definitions here, if you have two quantities, your starting quantity and your ending quantity, the absolute change will be the absolute value of the ending quantity minus the starting quantity. Your absolute change will always have the same units, and we'll talk more about units in the second half of this module, but you will have the same units because you're just subtracting two numbers with the same units. Now, when we do a relative change, we take our absolute change and we divide by the starting quantity, and that's important, it is the starting quantity. That absolute change from before was the absolute value of ending quantity minus starting quantity, divided by the starting quantity. I like the simplified version, absolute value of the new value minus the old value divided by the old value. That just is a little bit easier for me to remember. Now, relative change is giving you a percent change, which means your units in the answer are going to be just percent. Now, it's fine, to leave the decimal form, but it is better to turn that into a percent when you're talking about percent change. It'll make more sense to people. Another thing, sometimes we call the starting quantity the base of the percent change. So here, I'd like for you to try these first two problems using those definitions to see if you can get this set up, and pause the video here. When you come back, I will work through these examples. In example 1, the new quantity is 13,700. The old quantity was 15,300. So our absolute value of new minus old over old. Our absolute value of a negative, that's going to give us positive 1,600. And now we're ready to divide 1,600 divided by 15,300, 0.10, and we'll round that to 5, which means that this was a 10.5%. Now, we do like to talk about increase and decrease. Since this was going down and it said decrease, we do want to indicate that this was a decrease and not an increase. Sometimes you will see the decrease represented with a negative. Example 2, we have a flat tax of 1,000 imposed on two businesses in a certain locality. One was a small business with annual profits of about 50,000. The other, part of a national corporation, annual profits of about 50 million. So what would the percent decrease in profits each year based on this newly imposed tax? So it's a flat tax, everybody pays the same amount. So the small business after that tax will make only $49,000 instead of their old value of $50,000 over $50,000. So it's 1,000 over 50,000. And that is 0.002. And we get 0.2%. The national corporation, on the other hand, is losing $1,000 out of their $50 million. Now, because the problem went ahead and told us the change, that 1,000 is really an absolute change. So you can skip to the absolute value part. You can skip to this 1,000, and we will divide by their starting value. So that 50 million, 1,000 divided by 50 million is 0.00002, which is 0.002%. That is far less impactful to their overall profits. 0.2% versus 0.002%. Big difference here. So this flat tax is really going to hurt that small business a lot more. The base of a percent is very, very important. So we're going to work through a problem similar to a homework problem. And this is a good example of how you can express or word a comparison between two quantities in multiple ways, depending on which quantity you use as a base. People get this mixed up sometimes, and it leads to some wrong interpretations. So we want to be careful when we're dealing with percents and the base. Media outlets tend to choose the version that's going to sound more shocking or seem to have better support of their views, because media outlets are typically trying to make some money. So keep in mind that whenever you hear a percent on the news, you want to think about what that percent was representing. What was the base? So this example, a company's sales in Seattle was $330,000 in 2012, while their sales in Portland were $230,000 for the same year. So Seattle's sales were percent larger than Portland's. We can do Portland sales were percent smaller than Seattle's, or we can say Portland sales were percent of Seattle's. 3 different ways to represent the same thing. So this first one, Seattle sales, we are comparing to Portland. And so Portland would need to be the base, or that original. If we wanted to do this problem, if we look down here at the bottom, there's some space here. We would do Seattle minus Portland, and we would divide by Portland because of the way it's worded. That than is telling you that we're comparing to Portland. That's the original. Seattle was 33,000. Portland was 230,000. And we do Portland. That's 100,000 over 230,000. We get 0.43478, which is about 43.4%. Now, if we did Portland sales were percent smaller than Seattle's, here we are comparing to Seattle. And so our Seattle is going to be that base, that denominator, and we'll do Portland as the new one. So Portland minus Seattle over Seattle, we're going to get a totally different answer here. Because we're using Seattle as the base. This will give us 100,000. Again, in the numerator, that doesn't change, but we're dividing by a different denominator. And this is 0.3030 and so on, so about 30.3%. Thinking that in words, if we go back to question A, Seattle sales were 43.4% larger, or we could say Portland sales were 30.3% smaller. Both of those are accurate, so which one sounds better? And you would probably choose to report the one that sounds better for what you're trying to say. Now there is a third way of expressing this, and here our comparison is a little bit tricky for number 3 because we're not comparing two. Okay, we're not doing larger than or smaller than. We're going back to our original percent of. So this is actually back to what we did in the first video. When you want to do this one, change your solution to a percent and, or sorry, our final answer, we need to change to a percent because we are going to get a decimal. But here, let's write this as a expression. Portland were or is some percent of multiply Seattle. So Portland is 2,300 and then Seattle 330,000. There's your X, so we'll divide both sides by 330,000 to get our X. .6969, so that's going to be 69.7%. So Portland is 69.7% of Seattle's, yet a third way of expressing this. All three of these are correct. They're just different ways of presenting the percents. And so you've got to be careful about how you are interpreting your percents. So here's an example of how quantities measured in percents can be actually a little tricky as well. This is another place where we have to be careful with percents. A politician's support increases from 40% to 50%. How would you frame the politician's growth most advantageously? So we are already in percent. Because we're already in percent, when we do our absolute change, we're going to take that 50% minus our 40%. Our units are going to still be percent. So the absolute change is a 10% absolute change. This is where you will hear sometimes people saying percentage points. They've increased by 10 percentage points. That tells us that it is a raw 10, the actual percentage points increased by 10. That is different from an increase of 10%. If we wanted to turn this into a relative change, you would take that same 10%, divide by where we started, which was 40%, and you get 0.25, but this is yet another percent. You could also say that he had a 25% increase. Both of these are true. Both of these are accurate, but they're saying something different. A 10 percentage point increase is actually from 40 to 50%. A 25% increase is just growing 25% of where you started. So when you hear percent increase, be careful that it's not the percent. It's not like going from 40 to 65. Okay, so a 25% increase is relative to where you started versus a 10 percentage point increase is actually just adding 10 to wherever you started. So be careful when you're talking about quantities that are already measured in percents because they can get a little confusing.